Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 4th class in linear programming chapter. In last class, we done first 3 problems of exercise number 12.1. As I said, in this linear programming chapter, mainly 2 types of problems are there. One is linear programming problem which is having bounded feasible region. Another one is linear programming problem which is having unbounded feasible region. As I said earlier, first we'll finish all the problems which are having bounded feasible region. So in this class also I am going to do 3 problems which are having bounded feasible region. In today's class, whatever 3 problems we'll do, in that second problem if you observe, there is a line passing through origin. When a line is passing through origin, many students feel difficult to find solution of linear inequality which passing through origin. So I explained that clearly. You please observe that second problem in this video. You always keep these points in your mind. Linear programming problems we'll do stepwise. In step 1, by using constraints, we'll identify feasible region. Finding feasible region using constraints is step 1. Step 2 is identifying corner points from the feasible region, and substituting corner points in the objective function is step 2. Step 3 is by using that corner point method, we'll get maximum value, minimum value. By seeing that corner point table, we will conclude where the objective function is maximum, where the objective function is minimum. Before going to start this video, please drop a like for this video and share this video with your friends. Let's begin the class. In this question, they are asking maximize this objective function under these constraints. That means by using these conditions, these linear inequalities, these restrictions, we need to identify when this function is maximum and what is its maximum value. To solve this problem graphically, you please consider the constraints first. We need to graph these constraints. First, I'll graph this constraint x plus 2y less than or equal to 10. Graphing x plus 2y less than or equal to 10 is nothing but finding the values of x and y which satisfies this inequality. So, to graph this inequality, first we need to draw the line x plus 2y equal to 10. To draw this line, we need 2 points on this line. To find 2 points on this line, we'll consider a table like this. Okay. So, we'll write like this. One y coordinate is 0, one x coordinate is 0. Now, you put y0 in this equation. Then you will get x value. X value is 10. You put x0 in this equation. Then you will get 2y equal to 10, y equal to 5. So, now I know 2 points 10, 0, 0, 5 on this line. So, I can draw this line. Before drawing this line, I just want to consider this inequality also. To graph this inequality, we need to draw the line 3x plus y equal to 15. To draw this line, I need 2 points on this line. For that, I'll consider a table like this. In this, one x value, one y value. You write y coordinate 0, x coordinate 0. Now, you put y0 in this. Then what you will get? 3x equal to 15. X equal to 5. Okay. 5, 0. You put x0 in this equation. You will get y equal to 15. Now, you know 2 points 5, 0, 0, 15 on this line. So, you can draw this line easily. Now, first we'll graph this inequality. To graph this inequality, first I'll consider the coordinate axis. I'll mark these 2 points on the graph sheet. You observe here, this is the point 10, 0, and where is the point 0, 5? 0, 5 is on y axis. You draw a line passing through these 2 points. if you observe the inequality, this inequality is x plus 2y less than or equal to is there. When less than or equal to is there, then we will draw the normal line. If they give strictly less than, then we will draw the dotted line. So you join a line passing through these 2 points. So we drawn this line x plus 2y equal to 10. So what is this line? This line is x plus 2y equal to 10. To graph this inequality, you can observe for this line, this side is origin side of the line because origin is present here. And this side is non-origin side. So as origin side, non-origin side are present for this line, I'll put 0, 0 in this inequality. You put 0, 0 in this inequality. Then what you will get? 0 plus 2 into 0 is 0 less than or equal to 10. That is nothing but 0 less than or equal to 10 you will get. 0 less than or equal to 10. Is 0 is less than 10? Yes, 0 is less than 10. So you got true. As this is the fifth problem, you can understand which side to shade, why we are shading, right? So which side to shade? We need to shade origin side. What is this shaded part? This shaded part is the solution of this inequality. That means if you take any point anywhere, suppose if I take this is the point, this point if I substitute in this inequality, it satisfies. That means this point is solution of this inequality. Like that, in the shaded region, you take point anywhere, substitute in this inequality, it satisfies because that is the solution of this inequality. Now, I need to graph this inequality 3x plus y less than or equal to 15. For that, I need to draw the line 3x plus y equal to 15. We already calculated 2 points on the line. So I'll mark these 2 points on the graph sheet to draw this line. You observe 5, 0, 0, 15. 5, 0 is there here, 0, 15 is there here. As this inequality is less than or equal to, we will draw normal line passing through these 2 points. We are graphing this inequality. To graph this inequality, we drawn the line 3x plus y equal to 15. What is this line? This line is 3x plus y equal to 15. For this line, origin side, non-origin side present. This is the origin side. This is non-origin side for this line. So as origin side, non-origin side present in this line, I'll put 0, 0 in this inequality. I'll put 0, 0 in this inequality. Then what you will get? 0 less than or equal to 15. Is 0 is less than 15? Yes, 0 is less than 15. It is true. As it is true, we'll shade origin side of this line. That means origin side of this line is the solution of this inequality. You please observe the common region formed by these two inequalities. Where is the common region? Common region means the green color part as well as this light orange color part. Please observe the common region. Where is the common region? Okay. If you observe, this part is there, this shaded part. This shaded part is what? This shaded part is the solution of this inequality. That means in this shaded part, if you take any point, substitute in this inequality, it satisfies. That is the solution of this inequality. Now, we find some common region formed by these two inequalities. Where is that common region? Please observe. See, this part is there. This part is the common region. That means if you take any point in this common region, that point satisfies this inequality as well as this inequality also. So this region is the common region till now we got for these two inequalities. If you observe the question, in these inequalities, non-negative constraints are also there. What are non-negative constraint means? It means that x greater than or equal to 0, y greater than or equal to 0, both are possible in first quadrant only. So whatever the common region we got, that common region we'll take in first quadrant only. If you observe, where is the common region in first quadrant? Because we need to consider this inequality also. You observe, this is the common region. If I take any point in this common region, that satisfies this inequality, this inequality, this inequality. That means this is the solution of all given constraints. So this is the common region obtained by all given constraints. So this is known as feasible region. So you shade the feasible region. You observe here, this highlighted part is there, that is the feasible region. Actually, while solving linear programming problem, we do the problems stepwise. What is the step 1? Step 1 is graphing these inequalities and identifying feasible region. We identified feasible region. So with that, step 1 is over. Step 2. What is step 2? Step 2 is identifying the corner points and substituting corner points in the objective function. If you observe this graph, what are the corner points? First thing is, this feasible region is bounded or unbounded? This feasible region is bounded. So we will find the corner points. What are the corner points of this feasible region? See, this is 0, 0. This point is 5, 0. We know this point, right? And this point is 0, 5. And what is this point? This point we need to find. This point is point of intersection of this line and this line, right? So second step is identifying the corner points, substituting those corner points into objective function. So to find this point, I'll solve these two line equations. Solve these two equations to find this corner point. I'll take first equation as it is, x plus 2y equal to 10. This second equation you multiply with 2 on both sides. Then what you will get? 3 2s are 6x plus 2y equal to 30. Okay. Now you subtract to get x and y values. You can see this plus 2y minus 2y will get cancelled. X minus 6x is minus 5x equal to 10 minus 30 is minus 20. So what you will get here? You will get x equal to 4. Now substitute this x equal to 4 in this equation. Substitute x equal to 4 in this equation. Then what you will get? 3 4s are 12 plus y equal to 15. So y equal to 3. So you got the point x comma y. What is x comma y? 4 comma 3. So we got this corner point also. What is this point? This point is 4 comma 3. Now you know all the corner points. This point is 0 comma 0, this point is 5 comma 0, and this point is 0 comma 5. Now you form a table. We got total 4 corner points. One is 0 comma 0, another one is 5 comma 0, another one is 0 comma 5. At last we got 4 comma 3. Substitute all these corner points in the given objective function. What is the given objective function? Given objective function is 3x plus 2y. Substitute in 3x plus 2y, 3x plus 2y. Now substitute these points in the objective function. What you will get? 0, 3 5s are 15 plus 0 is 15, 0 plus 2 5s are 10. Now substitute this point in this. What you will get? 3 4s are 12 plus 3 2s are 6. 12 plus 6 is 18. So step 2 is also over. What is step 2? We identified corner points and we substituted corner points in the objective function. What they are asking in the question? They are asking us to maximize or minimize. They are asking us to maximize. As the feasible region is bounded feasible region, it is important. As the feasible region is bounded feasible region, from this table you identify maximum value as they are asking maximize. So 18 is the maximum value, correct? Out of all these values, 18 is the maximum. So what is the as the feasible region is bounded, we can conclude here the given objective function is maximum at this point 4 comma 3 and the maximum value is 18. So step 3 is conclusion. After seeing this table, we can conclude that as the feasible region is bounded, if the feasible region is not a bounded feasible region, we cannot conclude here. So what I'll write here, objective function, given objective function z equal to 3x plus 2y is maximum 4, 3. And what is the maximum value? Maximum value is 18. I hope you understand how to solve linear programming problem graphically. You observe this question, what they are asking, minimize and maximize. Both they are asking, minimize, maximize this objective function. What is the objective function? 5x plus 10y. Subject to given constraints. Observe the constraints here. Three main constraints are there. One is x plus 2y less than or equal to 120. Another one is x plus y greater than or equal to 60. Next, x minus 2y greater than or equal to 20. And as usual, they given non-negative constraints. This indicates that our solution is in first quadrant only. So, to solve this linear programming problem graphically, first we need to graph these inequalities. 1, 2, 3. To graph these inequalities, I need to draw the line x plus 2y equal to 120. For this, I need 2 points on this line. First, I will find 2 points on this line, and then I need the line equation x plus y equal to 60, and I will draw this line also by finding 2 points on this line. Similarly, I will draw this line. First, I will try to find the 3 points on this respective lines. By this time, you already know how to find 2 points on this line. You put x0 in this, you will get y value. You put y0 in this, then you will get x value. Now I know 2 points on this line, 0, 60, 120, 0. Similarly, I will find 2 points on the line x plus y equal to 60. In the same way, you find 2 points on this line x plus y equal to 60. You observe this interesting inequality. If I try to find 2 points on this line, what is this line actually? X minus 2y equal to 0. If you try to find 2 points on this line in regular procedure, what happens? You can check here. If I take xy, put y0 in this as well as x0, put y0 in this, you will get x0. You put x0 in this, then you will get y0. So it can be understood that this is the line passing through origin. Write this line equation in the form of y equal to mx. This is 2y equal to x, y equal to 1 by 2 into x. Right? 2y equal to x. So this is y equal to mx. Y equal to mx is a line passing through origin. We discussed these things in second class also. When a line is passing through origin, how to find solution of respect to inequality. Now you identify the line x plus 2y equal to 120. Mark the points 0, 60, 120, 0. 120, 0 is here and 0, 60 is here, right? So you draw the line passing through these 2 points. You can observe this is this line. For this line, origin side, non-origin side present? Yes. So you put 0, 0 in this inequality. So I'll put 0, 0 plus 2y less than or equal to 120. When you put 0, 0 in this, what you got? 0 less than or equal to 120. Yes, 0 is less than 120. This is true. So which side we need to shade? For this line, please observe, this is the line. What is this line? I'll write this line equation x plus 2y equal to 120. This line equation is x plus 2y equal to 120. You draw a line like this, and for as we got it is true, we need to shade origin side. So if we take this part, for this line, that is the solution of this inequality. If we take any point in this region, substitute in this inequality, it satisfies. This is the solution of this inequality. You keep in your mind that this side part, you see here arrow mark is there, na? For this line, this side is the shaded part. Okay. Now similarly, you to graph the inequality x plus y greater than or equal to 60, you draw the 2 points on this line 0, 60, 60, 0. Where is that? 0, 60, 60, 0. You please observe here. This is 60, 0. This is 0, 60. Draw a line passing through these 2 points. For this line, to graph this inequality, for this line also origin side, non-origin side are there. So what I will do, I'll put 0 comma 0 in this inequality. Put 0 comma 0. You put 0 comma 0 in this. In place of x you write 0. In place of y you write 0. What you got? You got that 0 is greater than 60. Is 0 is greater than 60? No. 0 is less than 60. So what is this? This is false. Right? So for this line, which side we need to shade? As you got false here, we need to shade non-origin side. Non-origin side means this side. If you take any point for this line, if you take any point in this side, that point satisfies this inequality. I hope you are understanding. So you need to shade non-origin side of this line. That is the solution of this inequality. You see here, we just kept an arrow mark to identify it easily. This is the line x plus y equal to 60. For this inequality, solution is this side, correct? I hope you are understanding, right? Now, it is important. Third one, you observe here, this is of the form y equal to mx. We know that y equal to mx is a line passing through origin. As m is positive, the line lies in first quadrant and third quadrant. In case if m is negative, the line comes like this. So what I'll do, I'll just simply draw a line passing through origin which lies in first and third quadrant, because this is in the form of y equal to mx. We know that it passes through origin. Now many students confuse here how to graph this inequality. X minus 2y greater than or equal to 0. It's a very simple thing. To graph this inequality, one problem is for this line there is no origin side, non-origin side, because this line is passing through origin. As this line is passing through origin, we don't get origin side, non-origin side. What I'll do, you take a point which is any one side of this line. You take a point and you make sure that point is which side. Suppose you take here 40 comma 0. 40 comma 0 clearly this side of the line, correct? So what I'll do, I'll substitute this point 40 comma 0 in this inequality. If it is true, that side only we will shade. If it is false, other than that side, that means other than the side of 40 comma 0, we will shade. It's not compulsory you need to take 40 comma 0. You can take this point also, 0 comma 60. 0 comma 60 is clearly one side of the line, right? This side of the line. You put 0 comma 60 in this inequality. If it is true, that side only will shade. Otherwise, other side will shade. What I am trying to say, when a line is passing through origin, you need not to worry. You consider a point either any one side of the line, but make sure that is which side. Suppose if I take this point is clearly this side of the line. I'll substitute 40 comma 0 in this inequality. If it is true, which side I taken the point, that side only I'll shade. If it is false, other side I'll shade. So here clearly 40 comma 0 is this side of the line. I'll put 40 comma 0. Put 40 comma 0 in x minus 2y greater than or equal to 0. Put what you will get. 40 comma 0 means x is 40 minus 2 into 0 is 0 greater than or equal to 0. So what you got? You got that 40 is greater than or equal to 0. You please observe here what we got, 40 greater than 0. Is it true or false? Yes, clearly 40 is greater than 0. So this is true. As it is true, which side we need to shade? This is the line now. As we taken 40 comma 0 is this side. As we got true, this side only we need to shade. I hope you are understanding. You please observe here, this is there now, this part of this line. Whatever you take here in the shaded region, that is solution of this inequality. If you take any point in this region, that satisfies this inequality. Now you observe the common region determined by all these constraints. See, 1, 2, 3. Main important thing is, as they given non-negative constraints, so our solution is in first quadrant only. You identify the common region formed by all these constraints. So you will come to know that this is the common region determined by all the constraints. this can be understood easily. So here, this is the feasible region. This feasible region is bounded feasible region or unbounded feasible region. Clearly it can be understood this is bounded feasible region. So we do this problem stepwise. Step 1 is finding the feasible region. See here, we identified the feasible region using constraints. This feasible region is bounded. So identifying the feasible region is step 1. What is step 2? Finding the corner points. You see, for this total 4 corner points are there. Okay. So you find the corner points. See, in these corner points, this corner point is, we know this is 60, 0. This corner point also we know. What is this? 120, 0. Now we need this corner point as well as this corner point. For that, how you will get this corner point? Solve this line equation and this line equation. You will get this corner point. You please observe, to find this corner point, I will solve this line equation as well as this line equation. This line equation is x minus 2y equal to 0 and this line equation is x plus y equal to 60. Okay, solve these two. You subtract x will get cancelled. Then what you will get? Y plus 2y is 3y. 3y equal to 60. So y equal to 20. Substitute y equal to 20 in this equation. Then what you will get? X equal to 40. So what is the point you are getting? X comma y is 40 comma 20. You can observe this point is 40 comma 20. Similarly, you solve this line equation and this line equation to get this point. So solve these two line equation. You can see when we add, this 2y will get cancelled. 2x equal to 120. So x equal to 60. You put x equal to 0 in this inequality. Then what you will get? You put x equal to 60 in this inequality. Then what happens? Here you will get 60 minus 2y equal to 0. So 2y equal to 60. So y equal to 30. So what is this point? This point is 60 comma 30. 60 comma 30 point is here. So identifying the corner points is step 2. So what corner points we got here? This point is 60 comma 0, 120 comma 0, this is 40 comma 20, this is 60 comma 30. All these corner points, you write it in a table and substitute in the objective function. Now you observe here, whatever the corner points are there, all these corner points you substitute in the objective function 5x plus 10y. Now you got the values like this: 300, 600, 600, 400. You please observe, they are asking maximize, minimize. As the feasible region is bounded feasible region, this is important. As the feasible region is bounded feasible region, in this table we can conclude where the objective function is maximum, where the objective function is minimum. We can conclude. So here, what is the minimum value? Minimum value is 300. You please observe, this is the minimum value. So we can declare that this objective function is minimum at 60 comma 0 and the minimum value is 300. I'll write that z equal to 5x plus 10y is minimum at 60 comma 0. And what is the minimum value? Minimum value is 300. Okay, they are asking us to maximize also. If you observe here, we got maximum value at 2 points. As the feasible region is bounded, we can conclude here feasible region is not bounded. If feasible region is unbounded, another step is there. As the feasible region is bounded, we can conclude here this objective function is maximum at 2 points. So I'll write that also. Z equal to 5x plus 10y maximum at 2 points. What are those 2 points? One is 120 comma 0, another one is 60 comma 30. So what is the maximum value? Maximum value is 600. So I hope you understand this problem. We learned how to solve given linear programming problem graphically. Now you observe this 8th question. Minimize and maximize this objective function. Mainly they given 3 constraints. I want you to understand this your own. Here they given non-negative constraints also. You find the 2 points on this inequality to graph this inequality like this. Similarly, you observe this is the line passing through origin. See here, y equal to mx, y equal to 2x. As m is positive, this line lies in first and third quadrant. You observe this is the line equation, y equal to 2x. Similarly, you graph this third inequality also. So we do this problem in 3 steps. What is step 1? Identifying the feasible region. You observe here, first identify the feasible region. Feasible region is bounded or unbounded? Feasible region is bounded. When the feasible region is bounded, as the feasible region is bounded, we can do this problem very easily. So step 1 is identifying the feasible region. Step 2 is what? Identifying the corner points. I want you to try this problem. That's why I'm not explaining all these things. You find the corner points, substitute the corner points in the objective function. And you see here, we got a minimum at 2 points. Minimum at 2 points. Maximum at 1 point. As feasible region is bounded, we can conclude here. What you can conclude? Minimum at 2 points. 20, 40, 0, 50. Okay. Maximum at z equal to 400. Maximum value is 400 at 0, 200. I hope you can understand this solution. If you like this video, please drop a like and share it with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye.